what if there's a vulnerability out there that could be equally big as Log4j? In today's episode of Threat Talks The Deep Dive, we discuss React2Shell, which could be the next Log4j. Let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
With me today is Yuri Wit, a SOC analyst and who knows everything about React2Shell. So welcome, Yuri.
Thank you for having me.
And my name is Rob Maas, field CTO at Ontoit. So before we dive deep into this vulnerability, maybe start with what is React?
Yeah, so React and also Next, because that was also affected, are JavaScript frameworks. They're basically a collection of pre-built libraries and tools for web developers to build their web applications.
So if I want to build a web application, React is a framework that I can use to make it nice and fancy.
Yeah.
Okay, and you said, okay, this might be the next big Log4j. Why is that?
The main components of that were that it is an unauthenticated remote code execution vulnerability, meaning that you don't need any prior authentication for an attacker to do before you are vulnerable. And a lot of default configurations of the React framework are vulnerable by default. You don't really need to do any fancy components, and even the vulnerable components don't even need to be really used in your web application for you to be vulnerable. So all that combined and the common usage of React all combined into super critical vulnerability.
Okay, and you also mentioned that a lot of people are working with React, maybe even without noticing it, because they are using AI with the so-called vibe coding thing to build their web applications. So that could even worsen or make the risk even bigger.
Yeah. If you Google tutorials for how to build your own first web app, usually you're linked to a tutorial that uses React or Next.js. So a lot of vibe coders by default use React, don't really know what is in it, and are automatically just vulnerable to this vulnerability.
So it's maybe not even the coder that comes with the suggestion, hey, use React, but the vibe coding as a result automatically already included React in your web application.
Yeah, exactly.
Okay, that makes sense. So we could have a lot of web servers running based upon React without the users or the builders even noticing that they are using this framework. Okay, and it is an authenticated remote code execution. So that means that these web servers that are, if it is a public web server, could be attacked by any attacker without authorization and just execute code on your server.
Yeah, directly.
Okay, let's start then. How does this vulnerability work?
Yeah, so the main crux of the vulnerability is in the term of serialization and deserialization. The way that a lot of applications work is that they need certain data, but to transfer that data between hosts over the internet, for example, you would serialize that data, which is like packing it into a specific format or structure, and then deserializing it back into its raw format on the server, on the client.
Okay, can I compare this a bit with if I want to send over a large file, that I zip it and then send it out, and then in order for the receiver to read or see it again, they need to unpack it?
Yeah, in a very basic nutshell, it is comparable with archiving files into a zip file. Now, it's a bit more complicated in actual programming language, of course, but that's the crux. Now, the main issue in this vulnerability was that the deserializer component in React, in the React server side, just trusts whatever data, serialized data, is given to it, and it doesn't do a lot of checks on whether or not it can trust that data. That's where the main issues arise. Now, how the vulnerability actually works in a high-level overview is, so you have the deserializer that grabs the serialized data and tries to put it back into a format that the server can actually use. And a second component is that in JavaScript, everything is seen as something called an object. And those objects also have parent objects called constructors, and those can also have constructors. And it is an entire chain of those constructors. And the way that this vulnerability works is that researchers found a method that they could walk up that chain of objects and their constructors to reach the function constructor, which is built into JavaScript, that just that is used to build new functions in code.
Okay, this really sounds as a really high level function.
Yeah.
Then they can be used. But this is only for React. It's not for other Java scripts.
No, it's also for others, but based on React. So the main two that we noticed in the news were React, because that's where the vulnerability was actually found. But you also have the Next.js framework, which is based on React. It was also vulnerable.
Okay, and it's the same pattern there. So serialization, deserialization, and then after deserialization, you get too broad access, I would say, to all the parent objects, functions, and parameters.
Yeah, exactly.
Okay.
Yeah.
Okay, makes sense. What if I'm an attacker and I see that you are running React? It's probably easy to read out what kind of web server you're using, what versions, and I see that you're vulnerable. Where should I start if I want to exploit this vulnerability?
Well, so that's the fun part of this vulnerability. You don't really need to check anything. You just send your exploitation attempt, and it either works or it doesn't. It's super simple as that. The complexity to exploit this vulnerability is super easy. It's super low, so you can just try it. There are very generic payloads that you can use that you can then just send towards a server and see whether or not it succeeded or not.
Okay, now I understand why it could be the next Log4j in terms of the impact and the size. But as an attacker, is it then, do I just send a packet, or do I need to have an input form on the web server, or where does it start?
Not even that. It's a single HTTP post request.
Okay.
So normally if you go to a website, you do a GET request to get the content of the page. Post request is the opposite way around. It's sending data towards the server. Very commonly used. That's not the issue. The issue is that if you have a React server in default configuration, you have those components that just accept those post requests. And so when you accept those post requests, the vulnerability can be exploited.
Yeah, so if you're running a React application, you probably have this React framework already accepting post requests, and therefore you're vulnerable.
Yeah.
Okay. That's makes
bad.
it a bit scary and bad indeed. So it's a remote code execution. I attacked your server, and now I can execute code. But what are the privileges of this code that I execute?
All the code that you execute through this vulnerability are executed with the same permissions as the server itself. So it just depends on which privileges the server process itself has when you start up the server, either it being in a container with root privileges or dedicatedly on the hardware directly, and then with the privileges of whatever user you used to run the server.
Yeah, so worst case maybe, and probably also very common, is that it runs under root because everything works then, especially if people use it with vibe coding.
Yeah.
Hey, it runs, so why should I bother?
Exactly, just run it as root.
Why should I bring the permissions down?
Exactly, yeah.
Okay, then, so it's bad, it's easy to exploit, but how can we mitigate this?
Well, there are a couple ways to mitigate this. Something that immediately comes to mind from a SOC analyst perspective is EDR. So it is remote code execution, meaning that child processes can also be executed via this vulnerability.
Yeah, so maybe one step back, EDR is the endpoint detection tool, and it's something you can run on endpoints.
Exactly, because if you have EDR running, a good EDR would immediately notice that your web server that normally doesn't run child processes suddenly starts creating a bunch of child processes. That's a very clear indication of that, and can sometimes, depending on the EDR that you're using, automatically block it based on that.
Yeah, so it can really be a prevention, a way of preventing it.
Yeah.
Okay.
Another ways of preventing it are just to patch
patches
your
are
software.
available?
Patches were immediately available upon disclosure, public disclosure, sorry, because the moment that the React development organization disclosed the vulnerability, they had patches ready for you to upgrade to.
And this is also for other frameworks that you know that might be impacted as well? Okay.
Yeah, those components were pretty much the same between those other frameworks. So just upgrading the relevant NPM packages, the libraries used for the framework, was enough to mitigate this vulnerability.
So one of the things, if you do vibe coding and you see that is using React, is to check these modules that are being used.
Yeah.
Okay. Any other things that we can do to mitigate
You can implement something called a WAF, a web application firewall, that literally just checks the incoming requests, whether they are post requests or other requests, and just matches them according to the patterns for certain exploitation attempts. Now, obviously, when such a vulnerability is released, most WAFs don't have the patterns to detect this, so it's not the best measure. But another thing that you can always do is just monitor the post requests towards your web server. If you don't necessarily need post requests to be made to your server, if you have a very static website that just displays your product or something, then you don't, just block all the other post requests.
Makes sense.
That would also help a lot. It's basically attack surface mitigation.
And if you want to use a web, I can imagine that the traffic should be readable, so you need to decrypt it if there's some encryption going on. Okay. Makes it a bit harder. Another thing I was thinking about is that you can probably also just limit the access. So if it does not need to be public accessible because you create your own to-do list, for example, that's often a good example for vibe coding. Why should that be publicly available?
No, exactly.
So that will also limit the impact. So this one was publicly disclosed. There are some proof of concept exploit code around. What should you do if you figure out that you might have been targeted or might have been attacked by this exploit?
Especially when you're talking about unauthenticated remote code executions, those are like the holy grail for attackers. You should just assume that you're compromised. If something like a vulnerability like this comes through, you just need to realize, hey, I can immediately be targeted by this, so I should assume that I am being targeted by this and react appropriately by resetting credentials, locking down your server, patching, doing all the necessary stuff that you would in any scenario. What's important to realize with this specific vulnerability is that it moved very, very quickly. So it was disclosed on the first day. Proof of concepts were already seen on the second and the third day. And the day after, a lot of publications already started seeing scanning attempts and exploitation attempts from threat actors in the wild. So it moved super quickly, which is why patching quickly enough is very, very important.
Okay. Do we have any idea how many vulnerable servers are still out there, or if it is still going on, or has everyone patched already?
I find it highly unlikely that everybody has patched. I think there are still many, many hundreds of thousands of web servers still vulnerable to this vulnerability, but it's very hard to guess. There's not really a super easy way to check using tools like Shodan, where you scan the internet, because it is truly dependent on the specific versions of the components that are vulnerable.
Okay, yeah. What worries me a bit is that this might be a very big vulnerability with a very bad outcome, but we don't hear many things about it. It was also, I think, released just before the holidays or during the holidays even.
Yeah, just before.
Just before, so it might escape a lot of people's attention. Okay, doesn't make it better.
No.
Maybe that brings us to a conclusion. So we have this vulnerability in React, which is an unauthenticated RCA, which means that attackers can just send code to your server and execute it, which is really bad.
Yeah.
Luckily, there is a patch available. So if you run React, or at least the React components, patch them. Also, if you have a web server that doesn't need public access, restrict it. That will help. An EDR solution you mentioned can help you to detect if child processes are being started by your server, which should not be the case. And if you have a good tool, then it can also prevent that. And with that, I think we're through this episode. So thank you, Yuri, for all the information.
Thank you for having me.
I'm not sure if I sleep well tonight. It's a bad vulnerability.
Yeah.
But thank you for all the information. And to you listeners, if you run React, go out, patch, limit the exposure, and hopefully you stay safe. And I hope to see you next time. So like and subscribe if you like what you saw, and see you next time.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and M6. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.